Hi everyone, this is a look at analyzing Lewis diagrams for atoms. Once we have a Lewis diagram prepared, we can analyze it in order to think about the unpaired electrons, which we call bonding electrons, and the pairs of electrons called lone pairs. Just as a reminder, we're always going to have the symbol and we're only showing the valence electrons on this style of diagram. And we're not going to pair up any electrons until each side, left, right, top, and bottom, are occupied. The elements that we're going to deal with are represented by these diagrams. We're only going to be dealing with hydrogen and nonmetals, and we're not really going to be dealing very often with the very large nonmetals. So, as a quick recap, here are a handful of Lewis diagrams for atoms, and we can analyze them. Hydrogen has one valence electron. It's in group number 1. It has one valence electron. So we're going to put one dot in its diagram. We could put it on any side of our choice, left, right, top, or bottom. Most of the time, people have a tendency to start on the left-hand side and work their way in a clockwise direction. However, it really doesn't make a difference. So here in this diagram, I have the dot on the left-hand side. We could have put it on any of the 4 sides, as long as it's not on a corner. Because it has only one electron and it's not paired, it has one bonding electron. One electron that's not paired. There are no pairs in this diagram, so it has 0 lone pairs. Hydrogen is the only element that we're going to encounter that has one valence electron. For us, there are no times that we're going to encounter 2 valence electrons. So we skip to 3 with boron. Boron is in group 13, which means it has 3 valence electrons. We've got to put 3 dots on this diagram. We can't pair them up until each side is occupied, so we have 3 unpaired electrons. Again, the orientation of these dots doesn't matter. 3 different sides. I have them on the left, top, and right-hand side. We could do it in a different way, and it would still be 100% correct. When we look at it, we see that these electrons are not paired. They are all bonding electrons. So boron has 3 bonding electrons, but none of those electrons are paired up. It has 0 lone pairs. Boron is the only element that we are going to encounter that has 3 valence electrons. Next door are carbon and silicon, and they each have 4 valence electrons. They're in group 14. These 4 valence electrons are all on different sides. So here, this is the only way that we can show a Lewis diagram for a carbon atom or a silicon atom. There's not a variation to it. It must be one of those styles. These electrons are not paired. Each of them is on a different side, so we have 4 bonding electrons, and there are no lone pairs. Carbon and silicon are the 2 different elements that we are going to encounter that have 4 valence electrons. So the only one with 1 is hydrogen, nothing with 2. Boron is the only one with 3, and carbon and silicon, 4. Next door in group 15 are nitrogen and phosphorus. Yes, it's true that there are larger elements below. However, it's unlikely that we're going to encounter them. With a total of 5 valence electrons, one of the pairs is going to show up this time. So we have nitrogen with 3 unpaired electrons and that one pair. That pair could have been on any side. It's traditional to show it on the top, but the pair could have been on the left, the right, or even the bottom, and then the other 3 sides with 1 electron each. Here, there's 3 electrons that don't have a pair, 3 electrons that are alone. Those are 3 bonding electrons. Nitrogen and phosphorus both have 3 bonding electrons. But there is this spot where they're paired up. Nitrogen has 1 lone pair, and so does phosphorus. Notice that because they're in the same group, the diagram for them is the same. The way that we think about bonding electrons and lone pairs is likewise the same. Elements in the same group always have the same number of bonding electrons and lone pairs. Next door to those, in group number 16, are oxygen and sulfur with a total of 6 valence electrons. When we put 6 dots around the symbol, we find that there's 2 unpaired electrons, 2 bonding electrons, and 2 lone pairs. Here's a pair of electrons on the left and a pair of electrons on the right. 2 pairs, 2 lone pairs. It's a little bit of a strange name. Finally, in group 17, we have fluorine, chlorine, bromine, and iodine, which I did not show, with 7 valence electrons. When we add the dots into our diagram, we end up with 1 unpaired electron, 1 bonding electron for a fluorine, a chlorine, and also for the 2 that I did not show, for bromine and iodine. And there's 3 spots where the electrons are paired up, 3 lone pairs. Halogens, fluorine, chlorine, bromine, and iodine, all have 1 bonding electron and 3 lone pairs. When we do our work with molecules, building off of this idea, these ideas of bonding electrons and lone pairs, in combination with this style of diagram, is going to lead us quite far through the unit. This style of diagram, they're basically all here. It's the symbol and only the valence electrons. Be careful about being neat and tidy. We don't want to have any dots on the corners. In certain cases, there's going to be different ways we could show it. This dot is here on the left. It could have been on any of the sides. However, there are certain times, like with carbon and silicon, where there's only one way to show the diagram. As we move forward, the number of bonding electrons is going to be a significant thing, as is the number of lone pairs. And I hope that helps.